Ahmed wants to predict which customers would like his new shawarma combo. So he collected a bunch of user data again. As we can see, he collected the information per customer of the generation, and if they have a fade, and if they are male or female. And then also the feature we want to predict, of course, if they like the combo or not. He wants the prediction to be easily understandable. So not just some numbers or anything like that. He wants a very clear rule that he can follow in his day-to-day business. This is where predictive rule learning comes in. This builds upon our last video on subgroup discovery, which introduces rule learning in general in a descriptive way. And now we will look on how to actually use rules to predict. You can watch my last video about this, but I will also quickly recap everything right now. So if you remember from the last video, we have a rule like this one. If gender equals male, then positive, meaning likes the combo. And then with that, we try to, with this rule, predict the outcome. So in this case, you can see the first row right here, it would predict it correctly, but then the next row, it would actually incorrectly predict it. So the person actually didn't like the combo, but it predicted yes. This means that this rule, of course, is flawed. We would then actually plot this rule on something called the coverage space, which you can see on the right. We have here on the left the total number of all positive examples, and on the horizontal, we have the total number of negative examples. And then here, our rule 1 basically tries to see how many positive and negatives it actually got. We then used for the descriptive method something called top-down hill climbing to actually find these rules. And we actually then used heuristics to see how good or bad a rule is. And then we tried to combine them with the next generation of rules and so on, and try to see how good this is. In the last video, we got with this the rule, if generation is Z and gender is female, then it's positive. So what we want to do now instead is to create a list of rules that would help us predict if new customers will like the combo. So in the last video, we did this basically in a descriptive way, meaning we described the data set with rules. And now we want to have a list of rules that would help us predict future ones. So here an example of how the final solution might look like, where you have here the set of rules, where if female and Gen Z, then yes, then they like the combo. If male and millennial, then yes, then they would like the combo. And if has fate and Gen Z, then yes, then they would like the combo. And everything else would be no, meaning they would not like the combo if they don't fall into these 3 categories right here. So let's say this person now comes in, let's call him Toby. He comes into Ahmed's store and we want to try to predict if he will like our combo or not. So he is Gen Z, he's male and has a fade. Let's see, our first rule is if male and millennial, then yes. This is of course false because he's Gen Z. And if has fade and Gen Z, then yes. And he does have a fade and he is Gen Z. So we basically therefore predict he will like the combo. And the answer is yes, he actually liked the combo. This is how we predicted it. Now let's say his little brother, I don't know, let's call him George, comes in and he's alpha. So generation alpha, he's male and he does not have a fade. And we predicted again the same way. And we find that actually none of the rules fit. And therefore we predict that he will not like the combo. So, but how do we get these rule sets? This is where an algorithm comes in called separate and conquer. Now let's try to actually go through this algorithm together. So here on the left, we have our data set again. And we start with some rule, like let's say this one. If male and millennial, then plus. So if there's a male and they are millennial, then they would like the combo. These rules that we're trying to get are the ones which would basically have the highest correctness which means they have the most positives and no negatives. So we take this and then we try to plot it this time from the bottom down. So we go here and we plot on our coverage space here that we predicted with this rule number 1 that they have 0 negatives and 2 positives. As we can see, this is consistent over the entire data set, this rule. Then after that, we basically reduce the coverage space, meaning we remove all of the examples that we just basically were able to describe with this rule. So we remove it, and now we have less data points right here. So we try to go to the next rule now, which is if the person has a fade and is generation Z, then plus. As we can see here, it's not quite consistent, as we do have here a rule, which, you see here the third rule, generation Z, and has fade and male, but they don't like it. This means that there's a tiny bit of an error here, which might not always be bad, because if there wouldn't be any error whatsoever, it could also mean that we're overfitting the data. As before, we remove the examples and make the coverage space then smaller. And then we go to the next rule. So here, the next rule is if male and Gen Z, then plus. So let's see where that would fit. We have here these examples right here where it would fit. And again, like the last one, we had 2 positives and 1 negative with this example. So we again remove the points on the data set and reduce the coverage space again. There we go. And then we have this data set right here. Now we have here one final example or one final rule, which is if generation Z and female, then yes. Then we can again remove this right here. And then we only have this left. And here we have our final rule, which is of course else no, meaning if all of these don't apply, then it is a no. And we do that. And yeah, that is then our rule set that we have just learned, and we have gone through all the examples, and our data set is now empty. And here are the rules. So if male and millennial, then yes. If has fade and Gen Z, then yes. If male and Gen Z, then yes. And if female and Gen Z, then yes. Now we can do something called pruning, where we basically look at our data set and we can see where there might be some inconsistencies or things that we can basically reduce. So one thing that I immediately see is here on the bottom, if male and Gen Z, then yes, and if female and Gen Z, then yes. Those two are specific, and maybe we can just summarize it into if Gen Z, then yes, because there are only male and females in this data set, meaning this rule would have the same weight as just if male and Gen Z or if female and Gen Z, right? So we can reduce that down. So if Gen Z, then yes. So now we basically pruned a rule and reduced it down to only being one rule like that. So it was 4 and now we have only 3. There's also something called pre-pruning, where if we have here the coverage space right here, we see there are like these black areas, right? And there are some different formulas that you can use for heuristics to basically prune away all the dark areas. So we basically don't have these areas in the middle. And this is very important because areas in the middle would basically mean that it's random. It's either yes or no, 50-50% chance. We would rather have rules that are definitely no or definitely yes. And here are some different ways of doing it. The support confidence filtering, CN2's likelihood, and fold MDL based. So now with our rule set, we can try to actually, again, predict, let's say, little George, I think I called him. And let's see again, he is alpha and he is male and he has no fade. And it would say that he still doesn't like a shawarma. And so Ahmed basically says, you won't like this, go out of my shop. I don't need you as a customer. Thank you. And yeah, that was predictive rule learning. The sources, like the last video, were on a course on computational data analytics by Johannes FK at the JKU. I thank you very much for listening, and I hope you learned something.